Hey there. Hey there, how you doing? Welcome back to the channel. So today do another update on our vacuum fluorescent display clock. So here I have the two digits and they're, going through different digits and stuff like that. Just not doing too much at this point. But I was doing a lot of experimenting with trying to build together like a dual digit and stuff like that. And then what I was trying to do is I was trying to figure out like with proto boards and stuff. I was trying to figure out like, well, how I should organize it to get all these digits in there. And then what I really found was that it was just, it was getting to be kind of too much. So if I look at some of the stuff that I did, I try to put like two digits together and like this and that kind of a thing. And so that was probably came out better than some of the other ones. But the thing is, the way they are, it's just trying to get it organized. It's just so tedious. And then I was trying to do soldering and things like that. And it's just not really coming out the way I want. It's really not looking as clean as I wanted it to look. So kind of the direction I'm going in is I'm actually going to design an actual printed circuit board. And so we'll go through what my plan is for that at this point. Now, one of the things is I got over here, the red module is the high voltage, 20 voltage. But, I had that problem with the 1.5 volt, which was a 317T variable regulator. And that thing was just a mess. And now I replaced it with this module over here, this little blue one. And this guy is a step down voltage regulator module. So that's generating the 1.5 volt. And now, and I know you can't really see it well, but what I can say is that if we, let's see, there was a place where it looked actually maybe okay. Maybe like that. Yeah, I don't know. But whatever, it's actually really good. It's really stable now. The digits aren't dimming. And most importantly, if I touch these, not even warm. None of these are warm. So the point is that the efficiency has become critically important here on that, because as I showed that last time, it's like, that 1.5, that, the voltage drop from 12 down to 1.5 was just killing us. So now what I'm doing is I'm looking towards kind of, what I'm looking at is like, okay, well, maybe because I'm not really happy with the way, the hand assembly is going. So I'm thinking like, okay, well, let me look into doing a circuit board. So it turns out, and let me try to share this. It turns out that there's actually, for relatively cheap, there's a lot of, there's a couple suppliers. I noticed it on DigiKey. They had some DK Red service that was like literally like $100 something for like 4 boards, just two-sided. They have to be really simple. And so it's kind of thinking like, well, maybe I need to look into that. And so what I did is a buddy of mine had pointed out this easy EDA thing. And he also pointed out that they actually kind of connect up with a board manufacturer as well. So I may, look into that. So basically what I'm doing is I'm trying to figure out like, okay, draw the schematic. So I'm going to draw the schematic, and then from the schematic, you can basically create a printed circuit board. And so basically what's happening here is you have, your schematic view. Like here I have my 5 volt regulator, and basically you wire it up electrically, and then but it also has a physical view on the printed circuit board. So like, for example, that's the one over here, this guy, this U9. So basically you can lay it out on the printed circuit board. So what I was doing, so I did an experiment, and I'm like, okay, the all 12 digits, it was going to be huge. I had the board going way out to here, and it still wasn't big enough. I'm like, okay, that's just too much. And the way at least one of these services, the way it worked, the service it was like minimum 4 boards, and it was like $100 for 2-layer boards. And they make it really simple. It's like, just 2 layers. and they don't do manufacturing checks and all this stuff. This really, I assume what they're doing is they're putting these big boards through with a whole bunch of other designs, and they're just marrying them all onto one manufacturing, and then they'll just cut out your boards for you, something like that. So yeah, so kind of looking at that. But so the point is that you know, I have to get a minimum of 4 boards, so it kind of makes sense to build something, you know, split it up so that modulize it. Now, if I did like 2-digit units, that would be kind of really small. I could do 4-digit units. But what I decided on right now is 6-digit units. So basically what I'm going to do is I'm going to do a schematic for 6 digits, and then I'll have 2 of those, and I'll assemble 2 of them. And that will make basically the complete clock that I want. And so here's the preliminary design on it. And so what I have here schematic wise, I'll just have, you know, my power supply. So it's going to be 17805 per 6 digits, and then one 1.5 volt and one 20 volt module. So here's the schematics for that. And so we'll have a total of 6 digits here. So we have the 2 digits here, and basically, you know, we're going to have our shift register and our driver chip, and then we'll have our tube here, and we'll just repeat that and get this all wired up, and that'll be good. And then, you know, the main thing I was doing here was really the layout, trying to fit it. So what I was thinking, I was down to 2.5 by 7, and so 7 is about the end here. It's about, comes out to here. It's not shown yet. But one thing is I was trying to do 2.5, and that wasn't enough. So what I really have to do is I have to, let's see if I can move this. Yeah, so I have to go something like this. So it's going to be about 3 inches. That'll give enough room for this. And then I'll have, you know, little jumpers here and there. And the jumpers are how I'm going to like actually connect up external things and do test points and things like that. And yes, I will need things like grounds between, so I'm gonna have to bond the grounds together, etc. Well, that's kind of interesting. I'm gonna use, yeah, I need to think about that. Okay, yeah, I need to think about that. So that would be the idea. And then this way, this will, I'll be able to get it to look much better. Now, I don't know. So yeah, so these are the modules up here. I'm just reserving space for them. So that's why I had to make it a little wider so I could get that done. And then we'll just have 6 digits here, and then I can put 2 of them together, and I'll have the pin headers for the, you know, serial data in, out, that type of thing, and the controls, and then we'll get those all wired up. And then you get 4 boards for like $125 manufactured, so that should be good. So I'll get 2 shots at it, basically to get the clock built. So that was kind of the idea. So that's kind of the direction I'm thinking of going, and we'll kind of see. So this is pretty cool, this EDA, easy EDA. This is pretty impressive. You know, they have a bunch of parts in there and everything, and like they have the parts I need. I mean, here it doesn't have to electrically be perfect. It just has to physically, pins and physically need to be what I want. And so that all works out. That all works out good. And I have to, you know, I think I have to make a part for the modules. So I'll have to make a part that will be, you know, basically my 20 volt module and my other module, and then have the physical layout, because I'm going to mount them on the board as I was showing here. You know, what I'm going to do, the little mini boards that is going to be mounted on the back here. And then this one, I will actually lay it down and put like some kind of, pour some copper there for heat sink, something like that. I think that's what I'm going to do. That's what I'm thinking. And that should do it. So I just wanted to give that little update on it. And I think that's good. I guess I still have a common board. I need to figure that out. See, the thing I really need to figure out. Ooh, let me see. I am doing this wrong. Okay, stop share. Let me share this one. Oh my goodness, what is it doing? Hello. Okay. Yes, let's share. Yes, this one. Actually, that's a good point. So I haven't figured that. I still have a common board. I mean, I think the thing is, I don't want to really stick the whole high pinout PIC board in there because I'd like to use that for other stuff. So I'd like to preserve the board with the chip that came with it for doing other stuff. And therefore, I could just, take the actual device with the real-time clock and I can put that on the board as well. I just need to figure out what support's needed. Now, if I do that, the good thing is that, actually, that's a really good point. If I do put that there, if I put that on the board, then it'll be running the program, et cetera, et cetera. Then I don't need all this isolation because I'll run the processor off the same voltage supplies as everything else. And basically the way it works is that PIC comes up and it just starts running the program that's been programmed into there. So it just starts running the clock. There's no real issue there. So that is, and then I probably wouldn't need these 74 HC14s either because it's really just slow because of the opto isolators. But the only problem is that you don't have a lot of good ways to program to test the code. So the thing is, if you yeah, that's the thing. If you it's like you make some changes to the code and you want to test it. Well, okay, then I have to pull the chip out. I have to program it, pull the chip out, physically put it in the clock. And I can do that, but you don't want to do that like hundreds of times. It'll just wear out the pins and you're liable to just break something. So that's the only thing I don't want to do. And see, if I put the device, this PIC device on the board, I don't have the programmer. So that's why I have to keep moving it back to the Curiosity board to program it and make changes. Because that board has like an Atmel FPGA and other stuff on it that's necessary to actually program the device. So it requires a certain amount of commitment to the code. So that's the part I don't know. And I want to do both. So basically what I need is, so I basically always need a daughter card. So basically I always need to be like, look, if I'm testing, I'm going to have the PIC running out here. It's going through this. And then at some point when the code is ready and I think all that's where I want it to be, then what I'm going to do is I'll put the device in on the board. So therefore I have to add the DIP for this PIC microcontroller in there. I have to add that to the board too. And so what will happen, let me see. So what will happen is that, so basically that PIC is something like this. And so, so if I wanted to do that, I could go over here and I could say, let's look for library and let's look for a peripheral embedded processor. We will look for microchip and we'll see what they have. Okay. PIC 24. I really just need something in a PDIP. Okay, so what I really need is just, if you look here at the footprint, I just need like I just need a DIP dual inline package. They call it PDIP. I think it's a PDIP 18 or PDIP 16. Let's see, do we see a PDIP? SPDIP, potential, SPDIP 28. Yeah, let's try that. So what I'll do is I'll go and I'll place it. And so here's the package. Okay, that's good. So now I have my my microprocessor. So, okay, so that's good. And I'll have to connect that up. And what I'll do is I'll save that. And what I'm going to do now is I'm going to go ahead and I'm going to update the PCB. No, keep going because I have disconnected nets and everything. So it wants to warn me. And then what I have, I'm going to apply the changes. And what does it do? And then here it is. Okay, so this looks about the right. This looks about the right package size. So now there it is. Okay, so the point is, it looks like I do have room for it. So I could put the processor on the actual board. And so what will happen is what I'll do is I'll have to like, oh my gosh, how am I going to do that? So that's the problem. If you look at that, see the thing that's going on. See, this thing is going to have a lot of these IOs. I mean, I'm going to use probably 10 or 15 of these IOs will be used to drive the segments and the controls and all that. So the thing is, if I'm driving it from on board, that's one way. If I'm driving it external, that's another way. And so I don't want to have switches or jumpers for all those. So I still don't know what to do about that, because I don't want jumpers for all of that. So I don't really have a solution. I mean, basically I would like to be able to like debug it and everything like that. And then be able to, and then put the thing in and then just physically test it. And it's all good. The clock is running and it's all cool. But the problem is I might need to like have jumpers for like all these control pins. So that basically what would happen is basically I need a mux. I need this way of saying, well, look, if I'm running external, then that signal RA is going to be driven externally. If I'm running internal, it's going to be driven internal. So I almost need like jumpers for each of these pins. It could be jumpers. It could be jumpers. So that makes it a little more complicated. So interesting. Okay, well, I think that's it for this one. But so basically the idea that I'm going is I'm going in this direction here. So I'm going to have, try to just do, it's going to be modular. And so I'll just have a 6-digit unit. And so conceptually, right, 6-digit unit, you can just make a conventional clock as well. We could do that. Now, the other thing I'm looking into is trying to figure out how to hook up to the atomic clocks, the real-time clocks. So I'm looking at that, and I don't know. Yeah, that's another question where that would fit in, because I don't know. Like in this place here, the way it stands right now, the wall wart that I have filters pretty good. And so I could just add a capacitor here, like 100 microfarad capacitor or whatever, 10 microfarad, something to do a little extra filtering, and I'm good. And that basically, those pins from the wall wart can just come right into this board and come right into both boards. And should be no issue at all. And then what I would have is, let's see, this guy here. Oh man, it's going to drive all these controls. And I have to configure whether it's a master or a slave, because basically I'll have only one of these devices in there. Wow, it gets complicated. Okay, well, that's it for this one. So yeah, that's it for the update. I still have a lot to figure out. All right, bye.